All right, in this video, we're going to take a look at building a function that is the taking a parent function, which we're going to be using x squared, and then applying some function notation to it, which is going to go ahead and take a look like that, and coming up with a new function and renaming it. Okay, so we're going to do this piece by piece, and we're going to start off with something that we've been studying, just a quadratic, which is going to be x squared. So what I'm going to do is that I'm going to start piece by piece, and I'm going to just do some notation off to the side and say that f of x equals x squared. Okay, and we'll start from there. So if I'm going to take this given f of x equals x squared and apply this function notation to it to get a new function, we're going to call that function g of x. We're going to do that piece by piece, and this is what we're going to just kind of like show you how to build that step by step. Okay, so the first thing that it tells us to do is that it says take the function and multiply it by 2. And so this is what we're doing right here. Okay, and so what I'm going to do is that I'm going to say, all right, well, there's 2, and I'm going to be writing this out here, and I multiply that by 2 on both sides like that, and you can see that I'm going to, as kind of like a shortcut here, put the 2 in front of the parentheses to form g of x. On this side over here, notice that I'm putting 2 on both sides. I'm just kind of like doing whatever one side doing to the other, just like we typically would with any algebraic notations. Okay, so when we move to the next part, which is going to be this x minus 3, you notice that I am going to go, all right, well, this is 2, and now I have f of x, and I'm going to be subtracting 3 actually inside the function, which is going to be inside the function on the right-hand side. Okay, and that's why we would put a minus 3 inside of the x squared for the g of x, which we're building right here. Okay, again, I'm showing you step by step right here, and then I'm also showing you just a kind of like an easier way right here to knock it down, just showing you where all the pieces go, so you could develop a quicker understanding of how to build these functions. Okay, and then finally we have this vertical shift of plus 5, and to put this over here on this side, we're going to go minus 3 and then add 5 outside of that function notation. Okay, and we're going to get 2x minus 3 squared, and then do a plus 5 on the outside, and doing a plus 5 right here. Okay, and so you can see that we have this part, okay, just looking at doing an observation here, okay, is that this right here is the same as this guy right here. So we're going to call that g of x, and g of x is going to be this new function that we made right here and right here. So to simplify everything down, what we're going to do is that we go g of x equals, okay, to x, a plus minus right here is just going to give us a minus. So x minus 3 squared plus 5. Okay, so to recap, what did we do? We took this function right here, we applied this function notation to it right here, and we formed a new function, g of x. Here we did it step by step, and this part right here is more or less just showing you how to build it step by step, a little bit of an easier way to go once you get a feel for it. Okay, so this method's going to work when you just have the parent function, okay, which is f of x equals x squared. It's just going to be a simple parent function. So what we're going to do is that we're going to do a few examples down below, and then pause the video for you guys to try, and then check your work afterwards. So I'll see you there. Okay, I'm going to do the first couple with you, and then just basically show you how to go ahead and do it using, again, if it just is a parent function that hasn't been transformed whatsoever, that is that no multipliers or vertical or horizontal shifts or anything like that, then you can just do kind of like this straightforward step. So first of all, doing the first one right here is that it says take f of x, which is this guy, okay, and we want to put 1 into a horizontal shift and 4 into a vertical shift. So actually 1 inside the function and a plus 4 outside the function. So to do that, we'd go g of x equals, and then we would have x squared, x plus 1 squared, okay, because we're putting that plus 1 inside where the x squared is at, and then a plus 4 on the outside, okay? And so we're calling that g of x. Pretty straightforward. So let's take a look at another one. We have this guy, and this one actually has a multiplier in front of it, okay? And so we're going to have to put a -3 outside of, when we do the horizontal shift, we got a -2 in there, so we've got x minus 2 squared, and then a vertical shift of -9. And so basically, that's how you do it again, only when it is in this parent function and it hasn't been shifted, transformed whatsoever. Okay, so go ahead and pause the video and give these a try, and then I will post the answers right afterwards. All right, so there we go. These are the solutions, okay, for these guys. So going through to check and see if you got them. Make sure that you got the parentheses in the right places. And just in general, just watching your pluses and minus signs and all that other good stuff. And notice that this guy over here, when we put the A, B, and C in there, this looks an awful lot like vertex form, right? And so, that's where the vertex form comes from, for the multipliers when A, B, and C just happen to be, they could be any number, right? So, all right, so let's take a look at now this business of what happens if the function that we are going to be adding function notation to has already been transformed, okay? So there's going to be a little bit different ways to go about that, and I'll see you in that next part. All right, this next guy is not in parent form, and so as I had mentioned previously, is that we're starting off with this, which actually has been multiplied and shifted around and whatnot, and we are applying this to it. And we're going to have to take a little bit of a different approach to that. So let me get set up real quick, and I'll show you what I mean. Okay, so the first thing that we need to do is that we need to multiply the entire function, f of x, that we start off with, which is this guy right here, by 2. And so this is how it changes, okay? So when I multiply the left-hand side, I'm going to get 2 times f of x equals, now watch, this is where a lot of students get tripped up, okay? So we have to multiply that 2 by the entire function, okay? Because the function already has stuff in it. So when we multiply, what we're going to do is that we're going to have to do like the distributive property right here and right here. And that's what we're doing on, if we look at this problem down below, is that we have to multiply in a 2 to this part right here, and then the back part as well. Okay, and the reason being is because of the distributive property that we're doing right here. And so that's going to give us 2 times a -4, which is going to give us a -8. X plus 2 squared, 2 times 5 is 10. Okay, and that is the same thing that we're doing right here, which ends up giving us this guy. Okay, now, so now it is going to be business as usual for the shifting. So the shifting that we got to do is that we got to go a -3 and a +1. And so that basically means is that when I write that all out, it's going to look like this. Okay, adding in the -3 and adding in the +1. Okay, and we do the same thing to this part right here, is that we're going to add in the -3 and add in the +1. And so at the end of the day, when I start to clean everything up, I'm going to get the following, okay? And so g of x is going to equal, bring down this part, the negative 8. And then I got x. So I got positive 2 minus 3, which is going to give me a negative 1 squared, and then plus 11. Okay. And you can see when I clean this part up as well, it is going to match that. And so a little bit different. You got to go ahead and just keep an eye on what you're starting off with. If it looks like something that is clearly not in its simplest parent form, then you know that you have to do some extra steps. Okay, so let's go ahead and take a look at another one, and then I will go ahead and let you pause the video and try the ones that come afterwards. Okay, so see you there. Okay, so here we go. Given this guy, what we're going to do is that we're going to apply this. Okay, so what we want to do is that let's go step by step. I think that's kind of like a two-step process that works best. Is that if you have this 2, okay, that is like adding a 2 and the 2 here from the last video. So we know that we're going to have to do the distributive property to both of those. So our next step is going to give us 2x plus 2 squared plus 10. Okay, and then we have this next part, which is we have our plus 4 and our plus 1. So if we want to do step by step, we'd have 2, okay, x plus 2, and then we have the plus 4 squared, and then the plus 1 to the 10. Okay, that's coming from right there. And at the end of the day, when I put all this together, I'm going to get 2x plus 6 squared plus 11. Okay, so that's what g of x would look like. And again, you can kind of visualize it out after you do a few. So I challenge you to do the next two, which is right here, and then check your answers versus mine. So go ahead, pause the video, check them out, and then see how you did. Okay, so there's the solutions, yeah, hopefully that you're getting the hang of it, and seeing how to knock these things out. And so what we're going to go ahead and do is to have a little bit more practice with these, following up. And yeah, well, any questions that you may have, go ahead and bring them on into class. So that's how you do that, and I will see you in the next video.